Good morning, good afternoon, good evening. Sounds like a start to Hands on SAP Dev, doesn't it? So welcome to Devtoberfest Week 2, bright and early on a Monday morning here in Western Europe. Thank you all so much for joining. I can see we got we just hit 100 viewers. Lots and lots of viewers already, and no question why. We have an amazing guest to talk to you today. Right next to me, in fact, you can see him as well. It's David. Say hi, David.
Hi, everybody.
So this is David Kuntz, and David works in the CAP team at SAP, and is one of my heroes. And I'm going to say that out loud, even though while he's next to me. Oh, I don't know which way, this way or this way. I don't know. But seriously, David is one of my all-time heroes. The things he does in the team, but also outside as well, is pretty incredible. In fact, I've got, if you're not aware of David's YouTube channel, he does all sorts of awesome stuff. I've got here the URL. You should go right now before we start and subscribe to David, because it's absolutely awesome content. I'm learning so much from David, and we're all going to learn a lot from David as well, because we're going to talk about CAP Node.js best practices. This is the best practices week of Devtoberfest, and David's kicking us off. So over to you, David. Maybe you can say a little bit about yourself as well, and then I'll let you just share your screen and go for it.
Thank you very much for this very nice introduction, DJ. So let me share my screen. I'm David. I'm one of the developers of the CAP Node.js runtime stack. And I've been at CAP for, I think, a few years now. And I really enjoy working at CAP. It's great, and it's a lot of fun. And I'm not only developing CAP Node.js, but I'm also processing a lot of issues, internal as well as external stakeholders have. So maybe you've already been in contact with me in one way or the other. And based on these issues, there are also always some common mistakes people usually do. And in this talk, I want to address them and show you how to fix them in the first place so they don't arise. And so I will concentrate on the CAP Node.js runtime stack, that is the SAP Cloud Application Programming Model in the Node.js flavor. So I'm not going to talk about domain modeling or CDS modeling, which is also an important aspect in creating an app, but mainly about the Node.js runtime stack. So the content which I'm going to present you today is sometimes generic with respect to Node.js. Sometimes it's specific to CAP. So for example, dependency management and error handling is very generic. It doesn't have to do anything with CAP, but the rest is all CAP. We go from transaction handling to database pool configuration to logging to generic handlers to environment configuration, testing, and also my favorite part, the REPL. So let's get started. So the first issue, which comes quite often, is suddenly my app stopped working in production because of some updates. And when I look at the configuration of the project, it's always something like this. In your package.json file, you have a dependency at SAP CDS latest, and there's no package log JSON whatsoever. And the reason why this is bad is that npm install determines the version based on the npm registry. And if you execute npm install at one point in time, the versions could differ to an npm install at a later stage in time, for example, when you deploy to production. So there might be surprises. And the solution to fix this problem is to manage your dependencies. And this is one thing which is great about microservices, is that you are in control of your dependencies. There's no single central system where all the versions are fixed. You can actually choose and pick the version you like. So you should always manage your dependencies. And one way to do this is to use a file called package.log.json. So we want you to stay up to date, but we also don't want you to break your productive app. And this package.log.json works like this. When you run an npm install, it will automatically create a file called package.log.json, and all the versions which you use during that npm install will be stored there. and it freezes the versions. That means the next time you run an npm install again, it will install the exact same versions. So there will be no surprises and you have a deterministic build. You should always commit this file to your GitHub repository, to your Git repository. That means when you push your app to production, you also push the package log JSON to production, and the npm installation process on Cloud Foundry, for example, will use the exact same versions which you use to develop and test your application. So there should not be any surprises. And once you have this package log JSON and you want to manually update, you can run the commands npm outdated to show a list of outdated packages, as well as npm update to then trigger this update process. And what we recommend you doing is that you write the following in your package JSON file, SLP CDS, caret 540, and we adhere to semantic versioning. That means we have here 3 numbers separated by digits, separated by points. And the first number is the major version, the next one the minor version, and the patch version. And with this caret, you automatically upgrade the minor and the patch version, and with the tilde operator, you automatically update the patch version. So let's look at this in an example. Dependency management. So I have here my package.json file, and in line 9, you can see that I'm using @SAP_CDS with caret 500. That means update this and this automatically. Now, I already installed the packages some time ago, and if I want to see if there are any outdated packages, I run npm outdated. And you can see that my current version is 506. And my wanted version is 553. So now I can run npm update to update my dependencies. And the versions are stored in this package log.json file. You should never look into it because it's quite lengthy. But here you can see all the versions installed in this npm install process. So they're fixed and there are no surprises. Okay, let's go to the next issue. Sometimes my app behaves in a very unexpected way, and this is quite a common generic issue. And this usually has to do something with error handling, also not very CAP specific, but more Node.js specific. If I look at the code, I sometimes see things like this. So it's a function pay customers. It takes a customers object. And then for each of those customers, it sets the payments paid property to true. And for whatever reason, sometimes people write try catch around it to catch for errors which could occur. And this is usually a bad practice. And there was also a scientific paper once which analyzed bugs in production with respect to how much code you put between a try and a catch block. And they found out the more code you put between a try and a catch block, the more bugs in production you actually have. So we should reduce this. And the reason why this is extremely problematic is just imagine that you have a customers array, so the for each method is there, but the 5th customer of that array doesn't have a payments property. Then all the customers before they got paid, the 5th one will raise an error and all the others don't get paid afterwards. So that's really bad. And the only thing you see is some console output, which you don't look at it, and you don't look at it anyway. So this is bad. So the reason why this is bad is that also programming errors are caught, and you should never catch programming errors. They need to be fixed. So they need to be fixed. And for unknown programming errors, the app must crash, fail loudly, and then fix. And I come to that point also later. So the way you should do it is kind of like this, and it totally depends on your code. So for example, if you know that customers is always an array, then you always know that there will be a for each method. You should know the data structures in your code base. And if you know that some customers don't have a payments property, then just do an if check, but don't use try catch around it. That also means don't program in a too defensive way. So the same function I could have written with additional checks, for example, to check if this is an array, or if C is defined, and so on. And it always depends on your code base, how far you should go. Don't go too far. Don't create too many checks, because as you can see, it becomes quite unreadable at some point in time. And always handle operational errors. So let's just say you have here an express handler, and you execute some HTTP request. That means an external system is involved. And whenever you have external systems or user input or whatever, things outside your program, then they will always go wrong at some point in time. There's not a single external system which is available all the time. Maybe the connection is broken or anything like that. So always make sure to handle those errors. In this case, this function could throw in if the system is not available, and you have to catch this error. There's no other way to do it if this function throws. Sometimes you also get a status of the response, then you can check that one. But if this function throws, then you have to catch it. Then you can log it and send status 502 bad gateway, for example. By the way, CAP's remote service API does this automatically. So if you use CAP and you have here a handler to read books, and you take an external service and run this query on it, and we find out that this external service is not there, then we automatically return bad gateway. So you don't have to deal with it in CAP. So let's go to the next issue. After some point in time, my app stops working properly. And this also has to do with error handling. And if I look at the code, I sometimes see things like that. This is the express middleware to catch all errors. That means you catch, and you can see it because it has 4 arguments here, error being the first one. And in this way, you catch all errors which happen during runtime and just send status 500 to the caller, which sounds reasonable at a first glance, but the problem is that all errors are caught. That means you are also catching unexpected errors, programming errors, which you should not catch. And the better way to deal with this problem is to let your app crash when there are unexpected errors. You always have a supervisor which will restart the app automatically. You should not leave it in a zombie state, because there might be side effects. So in principle, one can think that it's safe because an application is stateless. That means you can interchangeably use different instances of your same app, and everybody can handle your requests in the same way. There's no state stored. But the truth is that sometimes state is stored if you cache something or things like that. And if you have programming errors, then all things can happen. And there were many people who tried to recover the app, to not restart the app, to somehow catch the errors and continue. But it all failed. And in the end, the JavaScript community, I think they all say the same thing: crash your app. There's a programming language called Erlang, which has a quite sophisticated error handling approach. They have supervisor trees to recover some parts of the application which would crash when there's an error. JavaScript unfortunately does not have this, but at least we can reboot the whole app, and usually you have several instances of it anyway, so you will not have a downtime. So when there are unexpected errors, crash, fail loudly so you can actually get notified, fix it, and that's the way to go, the safest way to go. The CAP server also crashes when there are programming errors. So we have some central error handler, but we always check that if it's one of those errors, type error, reference error, syntax error, and so on, that we always crash the server no matter what. So the next issue. There's an error in my app, but I can't find the root cause. This is very common and very annoying if you're a issue processor and you have to find the root cause. Then sometimes you see something like this. You get a stack trace with some error happened, quite generic, and you don't know what actually happened. Add some main function, add some irrelevant location JS, line 3, column 9. And then you look at the code and it's something like this. So a try catch block around some function which might throw, and then there's just some error happened, which doesn't tell you anything. And then you look at it and you have no idea what actually happened. So the error information is lost when you rethrow the error, and that's a bad thing. What you should do instead is not lose this information when you rethrow errors. So how can we fix it? We can just throw the new error as before, but we can attach using object assign some new property causing cause, where we store the original error of this problem. And if we do that, then we can see a stack trace like this. Error, some error happened at irrelevant location. This is the same as before. But then we also have this cause property, the original error at the important function at the important location. And then we can actually find out what went wrong. So this is super easy to do, super important for error handling. Fun fact, there's also a new feature in V8, the JavaScript engine, which powers Node as well as Chrome. And in version 9.3, there's a new syntax for things like that, or not syntax, but a new way to do things like that. You can just write throw new error, some error happened, and then provide a second argument where you can provide the cause. So apparently the Node.js folks, they found out that this is super important, so that they implemented it in the standard. Next issue, and now let's come to the more CAP-specific things. This is a very common issue. After the first request, my app doesn't respond anymore. So that means the first request is fine, data is loaded, but then the next request doesn't return anything. And then I look at the code, and usually it's something like this. You have a CAP handler, service on read books. You take the request, you write cds.tx brackets .run select from books. It looks correct at a first glance, but there's something missing in the argument of this tx function. You don't provide the request object. And the reason why this is bad is because cds.tx without any arguments starts a new unmanaged transaction, which you have to commit and roll back manually. So the solution is to bind your transaction to the request. So it works like this, the same code, but here you provide the original request object. And what happens is that once you do this, it's linked to the request, because our database operation, they always start with begin, and they must end with commit if everything is fine, or roll back if some error happened. In SQLite, there are no parallel transactions. So you could have a deadlock. If one transaction is not committed and the other one wants to create a new transaction, it will wait until the first one is committed. If the commit never happens, you have a deadlock and the server hangs. Now, if you write cds.tx rec, then we link the life cycle of the transaction to the life cycle of the request. And once the request is exceeded, we automatically perform a commit or rollback. So it kind of works like this in a simplified way. You have your request start. Then during the request, at some point, you have some database interaction. Then we automatically send a begin. And then we immediately register handlers for the succeeded or failed event of the request. And if it's succeeded, we perform a rollback. If it's failed, if it's succeeded, we perform a commit. If it's failed, we perform a rollback. And then we execute the actual database statement. And once the request is succeeded or failed, then we emit succeeded or failed to execute those handlers. And because this is such an important issue, I want to show that in an example. Transactions. So here I have my cat service, and I have the same handler I've shown you before without providing the rec object in this handler. So if I run this, application, and I go to localhost, you can see the data is coming, so it looks fine. But now if I refresh it, you can see the spinner here that the server hangs, nothing happens. And this is the usual thing you would see. And whenever this happens, whenever your server hangs, what you should do is you should enable debugging to actually see what's going on. So what we can do is we can set the debug variable, the debug environment variable, to SQLite, for example. And if we run our app again, we can see all database statements. So you can see, for example, during the bootstrapping, some insertion of test data, and you always see begin, commit, begin, commit. If there's a commit missing, then something's wrong. So if we send this request again, you can see a begin, but there's no commit, because this is a manually handled transaction and there's no auto commit. So let's see what happens if we provide the request object and do the same thing again. Now you can see begin commit, and this is how it should be. Now if I refresh my page, everything works fine. Begin commit. So this is super important. So a very related issue is after the first request to my Express handler, my app doesn't respond anymore. So this looks exactly the same thing. You have here some Express middleware. Sometimes it's needed for you to have some Express handlers instead of CAP handlers. And you also do something similar. You write cds-tx-rec run select from books. And one could say that, okay, you provide the request object, so the transaction is managed, everything's fine. The problem is it's not, because the request object of Express is not the request object of CAP. These are different things, and you cannot use them interchangeably. So once you're in Express, you have to use your own transaction and manage them on your own. So a way to do this is to write const tx equals to cds-tx to create a new manually handled transaction. Then you can run your statements, and then you can await commit, or in case of errors, you can roll back. And here, when you catch errors, you also need to make sure in principle to not catch programming errors, so you can check that, but I didn't put that for simplicity. There's also in the newest version another syntax to do this, which is a bit simpler. So in your cds-tx function, you can also provide a function, a callback function, which gives you the tx object. And then you can just run tx run select from books, return this as your result. And if there are errors, then we roll back. If everything's fine, we perform the commit automatically. So this is also a way you can do it. Another issue, which is quite common, that background database operations have a strange behavior. So background database operations are usually something like this. You have your CAP handler on read books, where you want to perform some background task, which is an asynchronous function doing some database stuff, but you deliberately don't want to await this function, because you're not interested in whether or not there are errors or there's a result or anything. You just want to return the result of your next handler as soon as possible, because the user maybe is not interested in it at all. So you don't write await. But the problem with this approach is that, sorry, I forgot one thing. Async local storage, because to understand this issue, you first have to understand async local storage. And this is something which I really like. It's a Node feature, Node.js feature, which not many people know, but which is super useful. So that's why I dedicated a section to it. So instead of joining the transaction to the request object manually, like here, cds-tx-rec, you can also just write select from books and return this. So select from books is actually a CQN object, an object representing the query. But if you await this object, then we execute it, and we will look at the corresponding transaction to join it to that transaction. And it's a bit like magic, because we don't provide any rec object here. So how does it work? How does the CAP framework know which transaction to use, which tenant to use, which locale to use, and so on. And the reason is that we store the current transaction or the information about the current transaction in a property called CDS context. And CDS is a global object. So you would think that context is also a global object, but it's not a global variable. It's local with respect to the async context. And in order for you to understand how this is possible, I provided another example. Async local storage. And this, again, is completely unrelated to CAP, but we use it inside CAP. So we require the package async hooks, which you automatically have, so you don't need to install anything. And there's something which is called async local storage, and it's a very magical class. So we can create a new storage object using this thingy and store it here in this scope to which both functions here have access to. So it's kind of a global variable. And let's just assume for a second that this is just a normal global variable. We define two functions and we run first the first one and then the second one. So if I run function 1, then I run this run function on this storage object, and this sets the store to value 1, okay? And then I sleep, and because I don't await this function call, function 2 is executed, which sets the storage to the store to value 2, and then prints the store. And once this sleeping is done, function 1 prints the store. So if this would be a normal global variable, what would happen is this store would set to value 1, then the store would be set to value 2, it would be printed, and then printed again. So we would expect value 2, value 2. But because this is not just a global object, this is not happening. So let's run this, and you can see value 1, value 2. So this function did not override this value, because this storage is local with respect to the continuation. And here you have a different continuation than here, and that's why you have different values. Super useful, which we also use inside of CAP. So let's go back to this background task. Now you also understand a little bit why this might be problematic, because if you just run this background task, then we see that you await a CQN object. That means we know, because of this continuation, which transaction to use to join it to. But then you will have nasty race conditions, because we use the same transaction as the original request, but we don't await the result, and that's super nasty. So this is really problematic, and you will have race conditions. So the way to fix this is also to use a new function, which we also introduced in one of the latest versions, CDS spawn. So you can do the same thing, the same background task, but instead of just running it without awaiting it, you can just write CDS spawn and provide this function here. And then we will use an own transaction. And I'm going to show you that in example 4. Background tasks. So here I have my cat service. It's exactly the same example. And let me also enable SQLite debugging. I run my application. And now I trigger this books endpoint. And you can see that we have here a begin, we have a commit. So it looks kind of correct, but the background task is in the same transaction as your read request to books. And this is something we should not do at all. It should be completely disjunct from it. So what we do instead, we use CDS spawn to run this background task. So let's run this again. I refresh, and now it's correct. Now you can see that the original request has one transaction and it's committed. Everything's fine. The result is brought to the user. But then in another disjunct transaction, we actually do what the background task is doing. A lot better, and there are no race conditions whatsoever. So the next issue, some requests fail during high load. And there are some potential issues which causes for this problem. One cause could be, for example, that you didn't allocate enough memory for your application. And in Cloud Foundry, it's directly correlated to how much CPU you get. So the more memory you provide, the more CPU you get. And that could be a problem, that you run out of memory. But one common reason is that you configured your pool in a wrong way or in a bad way. So what happens in CAP is that we have when a request comes into the CAP server, we don't open a new database connection for every request, because that would be really slow. What we do instead is we keep a pool of connections, and whenever a request comes in, we just take one connection out of this pool and use that, and then give it back to the pool so the next request can use it. And for this pool, there are two important options. One is acquire timeout millis, and one is max. Acquire timeout millis gives you an option to set how long you're allowed to wait to acquire a connection out of this pool. And if it takes too long, we will throw an error. And usually this value is set too little. And that's why some requests get I think it's a 503, if I'm not mistaken. And the other option you can set is max. So make sure this is that you have enough time to acquire a connection from the pool. So set it to whatever is appropriate. And the other option is max, which is the maximum amount of connections we keep in our pool. So unfortunately, there's no one-size-fits-all solution. So you have to a little bit test how to adjust these values for your needs. It totally depends how much load you have, how much memory you have, and so on. We try to use reasonable defaults. For example, timeout millis is, I think, 1 second, and max is roughly 100. But adjust it to your needs, and you can do a lot with those two options. So the way to configure this in your require section, you can configure your database, in this case, Kindhana, and then you can say, okay, I want to have a connection pool where acquire timeout millis is 5 seconds, and my maximum amount of connections is, let's say, 1,000. All right, next issue. I can't use Kibana to analyze my logs. And Kibana is a way to monitor the logs in your productive environment. And usually people write something like this: plain simple console log my custom log output. And the problem with that is that you have no control how it's printed to the console, because except if you override the console log function, which you shouldn't do. And a better way to deal with it is to use log with a Kibana formatter. So we provide a function called CDS log, where you can provide a custom prefix. And then you can use this function to, let's say, write an info message, my custom log output. And then later on in production, you can set features Kibana formatter to true. And then we structure this output so that Kibana actually understands it. So let's look at this in example 5, Kibana logger. So again, we have our cat service as usual. And here it's the same thing I just showed you. We use CDS log with a custom prefix, and then we log info I am reading books whenever books are read. So let me run this application. And you can see once I trigger this endpoint, custom I am reading books. So far, so good. Now we can enable the Kibana formatter using CDS features Kibana formatter equals to true. And this only has an effect once we are in production. So we can set our node environment to production and run it again. And now you can see that all this log output is in a structured format. And if I run this endpoint again, you can see that everything here's I am reading books, but it's in a structured way, which can be understood by Kibana. And now you also know why we don't enable this by default, because it's just unreadable. I can't read anything here, but Kibana can, and that's the important part. Okay, next issue. How can I register generic handlers for all services? So that's also something which comes up occasionally, that usually if you want to register custom handlers. You create a new file with the same name as your CDS file, and then you can export a function which takes this service as an argument, and then you can register handlers for the service. But sometimes you also want to do it generically. And the way you can do it is by defining an own implementation of the app service. So in your requires section, there's this one special section called app-service. And here you can override the default implementation, which is used to power all those application services like a catalog service and so on. And you can provide an own implementation file. And this implementation file could look like this. You create a class myAppService, which extends our usual application service. And then you can do whatever you want. You can override the init function, for example, which happens during Bootstrap. And then you can call await super init. And then you can, for example, register some handler which always runs and always performs some log output, like shown before. Okay, so the next issue, how can I easily switch my environment? So usually you have a debug environment or develop environment where you develop your app using local tools, SQLite or local messaging and things like that. Then sometimes you may have a hybrid environment where you run your app locally but connect to the external services in the cloud. Or you have a production environment where everything is in the cloud. And sometimes you want to easily switch that. And the good thing about CAP is that we have profiles, which allows you exactly to do that. So here's one very trivial example. In your CDS require section, you can always have sections which begin and end with a bracket here. And inside this bracket, you can provide the profile name, in this case, production. And what it does is, if the environment is set to production, it will take the stuff which is written under it and move it one thing up, overwriting whatever you put there. And this way you can easily change your configuration based on some conditions, which is a great way. So to actually choose profiles, you can set environment variables, for example, to go to production as it's done in Cloud Foundry, or you can use a -- profile for various commands, for example, cds-env to look at the environment -- profile, or cds-run -- profile. And I'm going to show you that in this example here. Example 6, environment. So here I have a package.json file, and I have here a require section. And what I want, for example, I always want SQLite, but in production I want HANA. Or in production, I also want authentication, which I really don't want during development. And regarding messaging, during development, I want local messaging, but in production, I want enterprise messaging, MQP. So it can be quite sophisticated, many different profiles, many different ways to override stuff. And sometimes you're just interested in what is my effective configuration. So for this, you can just write cds-env. And this will print the effective configuration. And it's quite a big list of many entries. And you can also write cds-env get, and then whatever you're interested in, for example, requires messaging. And then you will only see that. You can also grab the list if you want to. And to see the effective configuration for a certain profile, you can write the same thing, but with -- profile, and then let's say production. And then you can see it switched from local messaging to enterprise messaging MQP. And to run it in a certain profile, you can also run your app with profile production, for example. All right. Now, one very important aspect to increase the robustness of your app is to actually test it properly using automated tests. And we have a quite new package released in the last version called CDS test. It's also documented in the last version. And it's super simple to use. First, you create the path to your project. So for example, you can use a path to join the current directory with ... to go one directory up. And then you just write const t equals to CDS test project. And then you have this T object, and it's quite cool what you can do with it. So you can write simple tests. This is a simple test with an async function, and you can just write await t get and then the URL of your application, and then you get the result of your request back, and you can inspect, for example, the data property value, and you make sure that it contains ID 1, stock 100, title, Wuthering Heights. And I want to show you that in an example. So I have here, again, some bookshop application, and I have here a test folder with some sample test. And here I do the same thing, which I've just shown you. I write const t equals to CDS test and then the path to my project. Then I create a chess test in this case. You can also use Mocha if you want to. And then we write await t get catalog books, and we make sure that it contains the book with ID 1. Then we delete the book with ID 1. We perform a get request again, and then we expect that it does not contain the book ID with ID 1. And then we create a new book. We send a post request to catalog books with this new book, send a get request again, and then we make sure that it's in this list of books. So to run it, you can, for example, use chest, and it will bootstrap this whole application, including all the test data which you provided in your CSV files, run the tests, and you can see it passed. And the last issue, which is not really an issue, but just a hint, is to use the REPL, which I really like. And it's just a nice way to play around with all the CAP APIs. And JavaScript is a dynamic language, and it has a great support for the REPL, so we should make use for it. So we can just write CDS REPL in this directory. And now you're in the REPL. And what you can also do, for example, you can write const t equals to CDS test for this root directory, which bootstraps again this application. And now you can actually interactively deal with your running CAP application. You can, for example, await t get catalog books, and you can get the result of your books. You can also connect to your services. For example, const srv is await CDS connect to my catalog service. Now you have the service, and now you can also run some queries. For example, await srv run select from books, and you get the result of your books. You can also create SQL objects using our query API, and you can inspect how we represent queries using our SQL object, for example. That's also a nice way to inspect it. And with that, I thank you very much for your attention, and I'm open for any questions you might have. Thank you.
Amazing. Thank you. Thank you so much, David. Do you want to please unshare your screen so we can get both of you and me back on the Zoom, which then comes through to the YouTube? David, that was awesome. That was absolutely, I'm supposed to be the host and, managing the chat, and but I was just concentrating on what you were saying. To be honest, three things come to mind immediately. I've written down loads of notes, some of the questions here. But first of all, may I commend you on what a wonderful development environment you have.
Thank you.
I'm a big fan, and again, I'll post a link to your YouTube channel, which talks a lot about that stuff, and more. Right? This is one of those videos where it's on YouTube, and therefore we can watch it back, the same URL. We all know how live streams and then replays work. I'm going to watch that back and pause and watch it back on slow speed because there's so many gems in there. But for me, you did save the best till last. The REPL as a concept generally is just absolutely awesome, as you agree, I know. I played with the REPL, but I've never really got that far. So this is a perfect opportunity for me and for all of us to sort of embrace that, and especially in the context of this new CDS test, which is an ideal sort of thing to run within this. So, I mean, you may or may not have the chat up there. You might see, but everybody's saying great session, super nice tips, great job, etc. I'll let you watch that and get embarrassed because we all think you're awesome. So I've written down some glasses. I've written down some questions or some comments, and also, folks, if you're watching now while I'm reading this, if anything else occurs to you. Ivona has said, great session from my colleague David. Just put it in the chat now. Mark Teichmann was talking about getting build errors with npm when you include package lock. I think Gregor and maybe it was Tobias as well. I think addressed that, but I think it was a super important point as well. Package lock.json was always one of those files like, what is it? Do I commit it to Git? Do I not commit it to Git? So I think you've answered that question very nicely, David, right?
Yeah, exactly. Absolutely commit this file. If you don't commit it, then and you use some dynamic version in your package JSON, then you will be always surprised in production. This is something you don't want to be.
It's funny because it goes also into the next point you made, which was about fail. Embrace failure, fail fast, don't catch programming errors. I mean, who thought we were going to get that on a slide on a Monday morning in a best practices week? But I think the way you expressed it and the way you explained it, it's clear to me that you want things to be ironed out and you want things to fail so that, in a microservice cloud native environment, you're not building up, error debt, right?
Yeah, exactly. It's a bit counterintuitive, right? Usually, what you should strive for is to keep the app running at all costs. To handle requests as many as you can. But in this case, it can be quite dangerous, and there were many people who tried to recover somehow from unexpected errors, but they all gave up. And the best thing you can do is to just let it crash. There were countless and numerous discussions which I had with colleagues, with internal and external stakeholders, and the best way. Crash your app, even if it sounds too hard.
Crash your app. You heard it here first. Amazing. Yeah. Somebody was saying, AK was saying, I think his client got went a bit funny and repeated stuff, but he and I think many others would love to see a full web, course on CAP. Now I've pointed to the CAP course on OpenSAP. But we're sending good vibes your way, David, and feed them back into the team. Whatever you can do would be awesome, right? And Ivona's on there as well. So Ivona, are you listening? Brilliant. So there's a question just here, and also I wrote down here. Somebody said, "Will David make the code examples available and also the slides?" Is that something you can do through? If you make them available through me, I'll share them on the
absolutely
on the GitHub page for this week. That's where they'll be. Brilliant, thank you. Yeah, also the async local storage, that you said that was quite a new feature, and that was a Node.js feature, not a CAP feature, correct?
Yeah, it's kind of new. I think it was released in so it was in the experimental phase for a long time, but I think in Node 12 it was the first time that it went stable. And gotcha. It's a great feature. It uses async hooks under the hood. It's quite interesting to dig into it. And I also created a YouTube video on my channel discussing that feature to make a.
In fact, I'm gonna get the channel again in a minute. One sec, I'll paste it in. I personally found. I've used profiles a little bit, but I think your slot on that was super informative, because I think many people out there might be wondering, what is this weird thing in square brackets? And it doesn't look right in my brain where you've got a kind and then a kind in a child. It's like, what's going on? So that was a great explanation, right?
Yeah, profiles are awesome. I mean, you always have to switch environments, and that's the way to do it in Kaplan, which I really like. I really like this feature.
Yeah. One more thing. I think somebody might have answered this. I'm not sure. I'm sure I saw somebody say this, but Vladimir's was saying, when you were talking about CDS test, and those new facilities there, Vladimir's was saying, can you use different user roles when testing?
Different what? Sorry.
User roles.
User roles. That is a good question, and yes, you can do that.
I think Tobias said, e.g., cds.user.default equals cds.user.privileged.
Yes. So two things. So first of all, using CDS test, it allows you to send requests to your running application. So whatever you can do with HTTP, you can do in CDS test. So you can use, for example, basic authorization to set some user up, which we do also internally in our internal tests. But you can also use the CDS APIs directly. You can, for example, use srv.run select from books. You can also execute things like that in CDS test. You can also run your handlers in CDS test. And for this, you can also set users. And we have some new transaction APIs. I showed some of them, CDS spawn I showed. So you could use, for example, CDS spawn to also set a user. CDS spawn takes another argument. Let me show you that. I'm not sharing anymore. But
yeah, you can share if you want.
Okay, I'll share real quick. So let me just write it here real quick. So you can use CDS spawn to run some function, for example, await select from books. And if you want this to have a certain user, you can use another parameter for this spawn function where you can provide the user.
Oh, yeah.
New CDS user privilege. I think it's something like this. I'm not
right. Something like that. Yeah.
Yeah. And you can also provide the tenant ID in this object. So that's also something which we improved in our recent version, that we make it as difficult as possible to mess up your tenant isolation. So if you don't provide the tenant here, then we use the tenant of the original request, which is super important for tenant isolation.
Definitely. Yeah. Gotcha.
Okay.
Thank you, David. So, okay, I think one more. I can see some questions in the chat, so I'll come to those in a second. I just want to make sure. I mean, this is maybe less a question for you, David. I know Ivona's on. I don't want to sort of put Ivona on the spot, but there were some comments about the CDS documentation as well. I think it was Mark that said that he finds it quite difficult to find what he's looking for. Maybe we'll take that obviously offline and figure out what that is. But also somebody said that when they're doing a search, they lots of Java results show up as well as Node.js. I don't know whether this is already been discussed in the team, but I just want to say that sort of on the recording so we've got it and we remember it, right? So that's I wouldn't expect you to answer that unless you want to, of course.
There's actually one thing. That's one feature we are discussing, so we're not rolling it out whatsoever, but maybe there will be some global toggle. We're discussing it to switch between Node.js and Java. So that means you would one time choose the flavor you want and then don't be bothered with the other one. So maybe we can make this work, but it would probably solve his problem, right?
You heard it here first. Look at that. What an amazing session. So just a couple more. So Semyon, and I'm reading this for the first time. Can app service feature help us to create error handlers for all services in our app altogether?
Yes, you can do that. There is this special handler which allows you to register error handlers, and you could use app service as a generic service to add this error handler globally, so to say, for all services, and then you would have it. Yeah.
Fantastic. And Semyon had another really good sounding question. Is there any possibilities for inheritance between services? You would love to have base service and then add more handlers.
Yes, you can do that. We have a class-based approach for registering handlers. In principle, what I showed you before, using this class, and then you can inherit it. And when you inherit it, you also get those registered handlers from the original service. I mean, you've seen it in app service, how I did it. I have overwritten the init method, And in this overwritten init method, I call super, await super init, and super init also could, in principle, register handlers. So yeah, you can build up your inheritance structure.
Fantastic. And I saw, so just a couple of more minutes, I saw a question from Speeds77, which Gregor Wolf has already answered. So thank you, Gregor. And thank you, everybody, for being so chatty and helpful in the conversation. So the question was, just for those wondering, the question was how to deploy CAP to S4HANA. And the answer is you can't really deploy it to S4HANA. You think you need to think in terms of, Gregor uses the right phrase here, this side-by-side approach, right?
Exactly, yes. So yeah. the main use case for CAP is not to embed it into ABAP or something that won't work, but you can deploy it on Cloud Foundry and then use it as a side-by-side extension to talk to S4HANA.
Exactly.
And it's very important that you don't pollute S4HANA with stuff. And that was done in the past way too often that
yes.
Every extension was inside S4HANA, or not S4HANA, but the predecessors, for example, and it got bigger, and more polluted. So the common guideline is, if it makes sense, don't leave the core clean and use side-by-side extensions next to it.
Absolutely. I mean, that in itself is a huge best practice, right? And so very appropriate for this week. So one final question from Santiago right at the end. In the future, and I think many of us can have a go at answering this question. In the future, will it be possible to work with more databases, brackets, Mongo, MySQL, etc.? Right now, I'll say right now, and I'm sure folks in the chat will be shouting, "Hey, look at what the community is doing with Postgres, for example. There's some awesome work that was showcased in last year's Devtoberfest." On that, loads of awesome people working on that stuff. But David, did you want to say anything extra to that?
Yeah, so we concentrate on HANA and SQLite for local development, but there is some excellent tooling out there for Postgres, as you just mentioned. Volker Butzig, Gregor Wolf, and so on. They did a fantastic job in creating this.
They did.
And if we want more databases, I mean, you can write your own client. I hope in the future it becomes easier to do that.
Mm-hmm.
There are also some hiccups in doing this, but it's in principle possible.
Fantastic.
But we're working on it to improve it.
I can't resist one. There is one more question from a hands-on SAP dev regular. So of course I've got to allow that question. A question from Niels. In addition to Santiago's question, are there any plans to support more event providers on top of Event Mesh, e.g. Kafka or even some Ethereum bridge? Now I know that that's possibly a question you might want to answer, David.
Yeah, we're thinking of supporting Kafka, but we haven't started Kafka development yet. We're just thinking about it, so I cannot give a clear statement on this, unfortunately. But we're at least thinking about it. Yeah.
Brilliant. So I think we're coming to the top of the hour almost. I want to give you, David, a massive, massive virtual round of applause. I'm not going to clap in front of this microphone. Thank you so much for kicking off Best Practices Week with such an awesome presentation. Do you have any last words?
Thank you very much for having me. It was quite a pleasure. I really enjoyed it, and I really liked it. Yeah, thank you very much.
You're very welcome. You're more than welcome. So just as a quick reminder, David and I will speak later this week. We'll put the content of what you saw. We'll link it from the Devtoberfest week to GitHub repo page. And equally massive thanks to everybody for joining. It's been really great. So thank you very much. And we'll see you for the next session tomorrow morning. Bye, folks.
Yeah, bye.
And we're offline.
All right.
David, that was